Hey guys, just to let you know that you can catch these lessons live every Thursday from 6 PM until 7 PM UK or BST time, and that will just allow you to ask any questions that you want and get some answers to them. Without further ado, let's get on with the lesson. Hey, welcome to the first of my live tuition lessons for A-level maths. This is going to be covering the Edexcel spec, and we're going to start from the very beginning. So this is year 12 content, but if those of you who are in year 13 or are studying for their exams, this will also be useful for you, but we're covering it from the very beginning. Okay, so with the first video, let's go through algebraic expressions. So what this covers are things such as indices and also rationalizing the denominator. Okay. So first off, let's do a recap of indices and all of the rules that we have. So if I'm going to use the letter x and a, so for example, if we were to have x to the power of a, and if we multiplied it with x to the power of b, what would that give us? Well, all we have to do then is add the powers together. That one's fairly standard. In A-level, you need to be able to go from this side to this side, but also backwards as well. So they may ask you to kind of split apart the two bases instead of having them combined. Okay, so with GCSE, you definitely went from the left side to the right side. In A-level, you can go from the right to the left. They can ask you to do that. The next thing is if we were to divide two indices, we would simply subtract their powers. The next thing is if you have a bracket, so x to the power of a to the power of b, you then multiply them together. The other things they can ask you to do is also square root them or root them. So for example, if I were to do, let's say, the square root of x to the power of a, my answer is x to the power of a over 2. So if a was 4, for instance, you would then half it and you would make it 2. So in order to generalize this, we can do b. The bth root of x to the power of a is just going to be x to the power of a divided by b. The very last one that we're going to do is the reciprocal. So for example, if we have x to the power of minus 1, that's the same as doing 1 over x. And likewise, if this is just any random number, so let's call it minus a, that's going to give us 1 over x to the power of a. Okay, so those are your basic rules of indices. It does get a bit more complicated with this, but generally speaking, the first question in your paper 1 is going to be doing some of this indices work. Okay, so it's one of the first few questions. Generally, it's the first question, but it can come up in the first few. And it's just guaranteed, I believe it's 3 marks. So there's a part A, which is relatively simple, and a part B, which is 2 marks, which is a bit more tricky. Okay, so that covers the indices section, right? The kind of basics you need to know. Rationalizing the denominator is something that's a bit more interesting. So if you had to put into your calculator something like 3 over the square root of 2, you wouldn't get this if you press equals. Now you do no operations on it, you don't need to write anything, just write 3 over square root 2 and you'll find that it'll actually give you something like this. 3 root 2 over 2. Okay? This is because whenever you have a surd, so a root number, it is an irrational number. It goes on forever. Okay? The problem with this is we can't really divide something by a number that is irrational. So we always rationalize the number on the bottom. Your calculator does it for you. Okay, so instead it's automatically going to do this. So the question is, how do we get from this side to this side? Well, if you want to get rid of a square root, you could say that you square the whole thing. That's a valid thing to do. But in this case, what we do is we simply times it by whatever's on the bottom. So in order to get from here there to there, if we have 3 over the square root of 2, to get rid of root 2, we times by root 2. And remember, with a fraction, whatever you do to the bottom number, you must do to the top number. So let's times it by the square root of 2. 3 times root 2 gives me 3 root 2. Root 2 times root 2 gives me 2. That isn't too bad, I don't think. However, unfortunately, things are never this simple. Instead, we're going to get things with multiple variables in the bottom. So we could go on to that, but what I think is the best thing to do is to actually go on and do some exam questions in order to give some context into what I'm talking about. So let's scroll down and start doing some of these questions. Question 1. It says to simplify this expression. So I'm going to do that over here. Okay, so if we have a look, it is to the power of 1 over 3. So one other thing that we could add to our kind of list of rules, which might be helpful, is if you look over here, a over b means it's the bth root of that. Okay, so what this is telling me is that this whole thing is being cube rooted. So 125 x to the 6 over 64. It's telling me the whole thing is being cube rooted. Okay? So that's what that 1 over 3 is. That would be the first step. Now all we need to do is cube root each and every one of these things, okay? Because there's no additional subtraction, we can just do that straight away. So what is the cube root of 125? Well, it's a calculator paper, so if you don't know, you can just use a calculator. But the cube root of 125 is 5. Now the cube root of x to the power of 6, again, I'm going to go through this quite slowly just for now. If you remember what we do when we have the root here, so this is this rule here, let's sub it in. In this case, b is 3, so we're going to have x to the power of something over 3, and a, in this case, is 6. 6 divided by 3 is 2, so it's just x squared, so it's 5, x to the power of 2. 64 cube rooted is 4. So 5x squared over 4 is our answer there. Okay, I don't think that's too tricky so far. So going on to the next question, question 2. Again, we write out the expression. We have something a bit more complicated. We have 2 x to the power of a half to the power of 3 over 4x squared. So again, remember your BIDMAS. The first thing we need to do is resolve these brackets. So if we again go back up to our rules, when we have a bracket, we multiply the power with the power outside the bracket. So if we look here, a in this case is a half, so we're going to have x to the power of a half, and b is 3, so it's going to be times by 3. Now the question is, what happens to this 2? Well, the 2 is also being cubed. So we have 2 times 2 times 2, which is 8 in front. And on the bottom, nothing changes, so 4x squared. Resolving this, we have 8x, and then we have a half times 3, so it would be 3 times 1, which is 3 over 2 over 4x squared. And that's it, okay? So it says simplify. We're not done yet. This hasn't been fully simplified. What we can first do is we can do 8 divided by 4. So we can cancel this down. Cancel, make that 2. So that makes that 2x. And then what happens when we divide x's again? Well, if we look back up here, a in this case is 3 over 2. B is 2. So we can just subtract them. Now 3 over 2 is 1.5, minus 2 is negative 0.5, which is minus a half. And that will be our fully simplified expression. Okay, so that's our answer here, that's our answer here. So far, so good. I don't see any questions, so we can move swiftly on to the next one. Question 3. Simplify, and then we have this. This is where it's going to get a bit more tricky. It's going to get a bit more exciting. So we have 216 x to the 6 over 27 to the minus 2/3. So a question that I often get is, which order do we do them in? So we have a fraction here. Okay, this over 3 means we're going to be taking the cube root. This 2 means we're then going to be squaring whatever we have. So we take the cube root and we square it. This minus also does something as well. So which order do we do things in? Well, it actually doesn't matter. But here's what I recommend. First things first, get rid of the minus. So all this minus does is it flips our fraction. So let's do that. So that's going to now become 27 over 216 x to the 6. That's 27y cubed. I actually didn't write the y cubed there. That's my bad. Perfect. And now instead of writing minus 2 over 3, it's just plus 2 over 3. Pretty easy, right? Now, in terms of do I square or cube root first, if I square it and then... Well, the thing is, this is kind of a legacy thing. Basically, back in the old spec, paper 1 was actually non-calculator. So you have to do these kind of mental arithmetic, which means cube rooting first made more sense because it makes the number smaller, and then you square it, which means you're squaring a smaller number. Imagine squaring 27, then cube rooting it. That would be a massive number. Trying to cube root that takes a very long time. It's very hard to work out. Because you have a calculator, it doesn't actually matter. But what I do, just as a leftover from when I used to teach the old spec, is I cube root first. Okay, so let's cube root 27. So that's actually 3. Again, you can just use a calculator for this. And by the way, this is all still in brackets. Y cubed and then cube root it. Well, if you look back at our rule over here, right? A is 3, B is 3, so 3 divided by 3 is 1. So we don't write the 1s in algebra, so we just leave that as y over. So the cube root of 216, again, you can just use a calculator if you're unsure, but this is 6x. And then again, the power, A is going to be 6 in this case, B is going to be 3. 6 divided by 3 is 2. Close bracket, and then we're squaring it. Squaring it, 3 squared is 9, y squared is y squared, 6 squared is 36, x squared is going to be x to the power of 2 times 2, which is 4. Okay, so these are 2-mark questions, so you should only spend a maximum of 2 minutes on it. Personally, I think that they should actually be 3, at least for question 3 it should be 3 marks, but you know, they are quite strict on this. Okay, so that kind of covers the basics. This is these first 3 questions are going to be one of the first 3 questions you take on the exam. There'll be a part A and a part B. Part A will be relatively simple. Part B will be somewhat similar to questions 1, 2, or 3. Okay, so this is 2 marks. You get 1 mark for the beginning, so in total it's 3 marks. Cool. Now, as part of a question, they can ask you to do something similar to question 4. And question 4 is express 9 to the power of 3x plus 2 in the form 3 to the power of y. Now, they actually kind of give you a bit of a hint here, okay? They tell you, so what they're saying is, what they're telling me is that it can be written as 3 to the power of y. So what do I mean by that's a hint? Well, I need to be able to change my base. This is another key skill in A-level, and it's going to come up in A2 as well. It's the idea of changing bases. When we do logarithms as well, we're going to be doing that. So how can I write the number 9? Well, 9, and by that I mean, how can I write the number 9 in terms of 3? Well, it's 3 times 3. What's another way of writing 3 times 3? 3 squared. I think you might be getting what I'm trying to do here. So I can write this thing here as 3 squared all to the power of 3x plus 2. Okay, and that equals 3 to the power of y. There are 2 ways to do this. You don't have to write this equals 3 to the power of y. If you don't want to, it's not really necessary. It's technically more mathematically correct, but you don't have to. And okay, cool. So what do we do here? Well, when we have a power to the power, what did we do? Well, we timed them together, so let's do that. So 3 to the power of 2 to the power of, so we have 3 to the power of 2 times 3x plus 2. Well, if we look at our answer, y is in the form ax plus b. So there is no bracket there, so all we need to do is expand the bracket, and we get 3 to the power of 6x plus 4. Okay, so all I'd do then is, that's technically correct, I'd get my 2 marks, but I like to actually be really explicit and say y is equal to 6x plus 4, put a little box around it. Again, the less work you make the examiners do, or your teachers, the more likely you are to get marks, okay? Because again, examiners and teachers, they make mistakes. So if you make your answer really obvious, so here's how teachers mark, just in case you weren't sure. They'll look at question 2, they'll look at your answer and compare it to the mark scheme answer. They won't look at the method just yet, necessarily. So if you put a box around your answer and they can check that your answer is 100% correct, they'll tick it, they don't even look at your method. Make it easy on them, okay? Question 5, it's very, very similar. Okay? Very, very similar. So express 8 to the power of 2x minus 5 in the form 2 to the power of y. So that they're telling me that you can raise this to the power of y. Okay? So I'll give you a few moments just to think about what you need to do. Okay, if we look back at the previous question, they gave us a hint, right? They implied that 9 can be written in terms of 3s. They're now implying that 8 can be written in terms of 2s. Okay, so if I write 8 equals. Now we have to think in terms of powers. In the previous example I said it's 3 times 3. Well, you would probably say 2 times 4. Not wrong, right? But we want it in terms of 2. So we could do 2 times 4. So in terms of 2s, that's 2 times 2 times 2, which is 2 cubed. Or you can just know that it's 2 cubed. So you know how in the previous part I said that since you have a calculator, this kind of thing doesn't matter, right? Like you can find the cube root of 27 and then you can square it on a calculator. The problem is knowing your square and cube numbers is really important, because like in this question, what would you put in a calculator to work that out? There's nothing you can put in. It's relying on your knowledge and your ability to see that 8 can be written as 2, in terms of 2. Okay? And this kind of thing comes up again in A-level maths, and again, when you go to university, the maths you do at university, again, doesn't really matter what subject you're doing, it's going to involve you being able to look at numbers and say, wait a minute, I can write that as this. Okay, so if you're doing physics, engineering, economics, maths, medicine, whatever at university, okay? So just knowing your square and cube numbers is quite useful. Again, it comes with practice, so don't worry too much about memorizing them. Anyways, that was a long tangent. So again, using the exact same logic I did in the previous part, I'm going to do 2 to the power of 3. And all of that is to the power of 2x minus 5. That equals 2 to the power of 3 x minus 5. Another question I get asked sometimes by sixth formers is, do I have to write all of the working out? I would recommend doing that. So the whole point of kind of learning during the year is to get better and better at exam technique and laying out your methods. The thing is, if you skip steps, you can easily make mistakes. So for example, in this part, some people skip this step and they'll write 2 to the power of 6x minus 5. I've seen that a million times. And these students are really bright, extremely bright. But because they look at this question and they think, oh, that's easy, they rush and they get the wrong answer. This is incorrect. Instead, times everything. And again, you may think, oh, that's a silly mistake to make. It is a silly mistake to make, but you will make them. And the first time you do some exams and tests at school, or whenever you do them, you'll find that you'll make silly mistakes. Everyone does it, teachers do it, doesn't make a difference, okay? Perfect. So, 6a. We have that given that y is equal to 2 to the power of x. It says express 4x to the power of x in terms of y. Cool. So what I want to do is basically make 4 to the power of x look like 2 to the power of x. How can I do that? Good question. All I need to do is do the exact same thing. 4 is just equal to 2 squared. So that means 4 to the power of x is equal to 2 squared to the power of x. Okay? Now, if I wanted to, I can just swap these around. Okay, but I'm not going to do that just in case it's a bit confusing. That would be 2 to the power of 2x. So in other words, it's equal to 2 to the power of x squared. Right? It doesn't matter which order I times things in. Y is equal to 2x, so it's equal to y squared. Okay? So I went a bit quickly, so let's just go over that one more time. I mentioned at this step that I could swap the x and the 2 around. Okay? The reason for this is multiplication is commutative, which means it doesn't matter which order you do them in. So if I have 2 to the power of x squared, it's the same as having 2 squared to the power of x. So if I swap those around, and again, this is what I mean by A-level maths relying on you being able to look and see the relationships, okay? If you had the foresight to look at that and say, okay, I can swap those around, you would get to the answer a few steps faster. Okay, there are some students, again, that would get 2 to the power of 2x and get confused, don't know what to do. Okay, get 2 to the power of x, doesn't matter how. All you need to do is factorize it out, or you need to swap them round, and you get y squared. Then says hence or otherwise. So again, in A-level maths, they love to use part A, B, C, etc. And you will always use the parts, so part A, in the later parts, especially when they say hence or otherwise. This word, hence, means use previous part. Okay, it will make your life a billion times easier, okay? So when it's saying hence, immediately I'm thinking, okay, I need to use part A. Now, let's have a look at our equation. We have 4 to the power of x minus 6 2 to the power of x minus 16 equals 0. Okay, it says use part A, right? That's what hence means. Well, I expressed 4x in terms of y. Well, what if I sub that result in? I get y squared. Does that help me? Well, okay, now I'm thinking y squared means I have a quadratic, which I know how to solve because I've done them a billion times before. 2 to the power of x is equal to y. So, what if I just replace that with y? Well, now I have a quadratic equation. So the question is now, how do you want to solve it? Doesn't matter. Okay, you can use the quadratic formula, you can factorize, whatever you prefer. If I use the quadratic formula, I get y is equal to minus b plus minus square root b squared minus 4ac all over 2a. So again, just shove that all in your calculator, you get y equals, so let's sub it in. Actually, I'll write down the substitution as well, just so you know. Minus, and again, write it exactly as I do. Yeah, use brackets and things like that. The number of times I've seen sixth formers mess things up because they don't use brackets is astonishing. So minus 6 squared minus 4, a is 1, c is minus 16. All over 2 times 1. So y is now equal to, if I just shove this all in my calculator, so minus 6. And again, please do this as well. Using your calculator is a massive skill that you need. And again, 80 students make mistakes on their calculators. First answer I get is 8. Or, because again we're using quadratics, which means there always is 2 answers. The 2 answers could be the same, but there are 2 answers. Or minus 2. Okay, am I done? Absolutely not. I have gotten 2 marks. Because look at the equation it asked me to solve. There is no y in it. Okay? So I have y is equal to 8. So if I do this over here, just because it's getting a bit messy, or y is equal to minus 2, I now need to sub in y is equal to 2 to the power of x. So 2 to the power of x equals 8. And we have 2 to the power of x equals minus 2. 2 to the power of x is equal to 8. Well, that means I know that it equals 3. And is there any value of x that would give me minus 2? Is there any power I can give that would give me minus 2? No. So, no answer. The answer is x is equal to 3. Okay, because don't forget, if you put minus numbers in the powers, it just puts 1 over that. So it doesn't actually make it a negative number. You can't put anything to a power and make it negative. Okay? Unless the base number is negative itself, which it isn't in this case. You can't swap signs like that. Okay. We've blasted through that extremely quickly so far. So that's question 6 done. I'm going to have to delete question 6 in order to do question 7. So I'm going to give you 2 seconds just to read through that, make sure it's all okay. Anyone have any questions? Okay, I think that's enough time. So let's get rid of question 6. Now let's do question 7. So solve the expression. That's 2x 5. Now, given that we've just done a question very similar to this, but it was split into two parts, right? This question was split into two parts. If you notice, the first part was 2 marks, second part was 3 marks, and this question is all just 5 marks. That's not a coincidence. In the later papers, they tend to actually split these questions into multiple parts, but they don't have to. There's nothing in the spec that says they do. Okay? So imagine if you just walked into an exam and this question came up. Using your knowledge from question 6, would you be able to do this? Okay, follow the same steps. Okay. What we need to do is substitute in something for 2 to the power of x. I'm going to use y, but I need to be able to write this in terms of y. Okay, it's a bit tricky. So, again, ideally, by the time of your exam and your mock exams, and even your end of unit exams, you should be able to get a look at this question and know exactly what to do. So bear in mind, we've just done a question exactly like this, so if you think that you understand it and you're good at it, keep that in mind. You've literally just done it. So, I need to write 2 to the power of 2x plus 1 in the form, so if I write here, in the form 2 to the power of x. So what things can I do? Well, first off, this bit here, this plus 1, that's telling me that I have 2 to the power of 2x times 2 to the power of 1. Right, but generally speaking, we don't write to the power of 1, so let's leave it blank for now. Okay? Now, if you're unsure, think about how you would do this. 2 to the power of 2x times 2, you would then add 1 to the power. You can't just add 1 to the x, you need to just put plus 1 on the end. Okay? Minus 5, I'm just going to sub that in for y straight away, minus 12 equals 0. Okay? 2 to the power of 2x. Again, if you want the model solutions, I will export this as a PDF afterwards, but bear in mind I have deleted some questions. So if you want the model solutions, just write them out yourself. It'll be good for a memory game, but you won't need to write out all of them. So all of the ones so far, you won't need to write out, okay? Just the ones that I'm kind of deleting. So how can I write this in terms of to the power of x? Well, if you remember rightly, when we multiply two powers, that means we put them in a bracket. So we'll do something like this. I want the x 2 to the power of x by itself, squared. Okay, again, you multiply those, you get 2 to the power of 2x. And there's a 2 in front of here, by the way, because we have that 2. Generally speaking, we put the numbers first. Minus 5y minus 12 equals 0. So now I can substitute in my answer. 2 to the power of x is y, so that'd be y squared minus 5y minus 12 equals 0. Once again, we're just going to be using the quadratic formula. So again, if I write it out, we're doing minus b, so in this case b is minus 5 plus minus the square root minus 5 squared minus 4, a is 2, c is minus 12. Oh. And then of course I cross out my powers because I'm an idiot. Perfect. And then 2 times 2. So that gives me a value of y of, well, let's have a look. Again, if you haven't deleted your quadratic formula on your calculator, as in the previous substitution, you can just change the numbers in it. And again, make sure you use brackets, okay? Every year I get a student that complains that they only messed up because they didn't use brackets. Okay, but you know, you won't be able to tell the examiner that, so there's no point in worrying about it. So that's minus 3 over 2. And y is equal to, change the minus to a plus. And again, just so we're clear, to do the plus minus, just do it with plus one time and then minus the second time. You have to change it. But again, use the arrow keys on your calculator to simply navigate through your thing. Don't write the whole thing again, that's a waste of time. Okay, so that's not our answer though. We have 2 to the power of x is equal to minus 3 over 2. And 2 to the power of x to 4. Again, you can't make a negative, so this doesn't give me an answer. X here, 2 to the power of what gives me 4? That's 2 squared, so x is equal to 2. That is your final answer. Okay, so hopefully not too bad. Give it a few moments for you to copy that down. So that's the other kind of, well, sorry, that's another type of question they can ask you to do with indices. If we go back up, this is one type, and this will guaranteed come up. Then you have things like this. Then you have solving equations like this. And again, these are 5-mark questions, so they come towards the end of the paper. But if you get one of these questions, you should be so happy, okay? Because this is 5 marks. Look how quick I did it, yeah? Realistically, you could jump from this step here to this step here, theoretically, or the step before. So 1, 2, 3, 4 steps, 5 marks. Okay, you can do this question in about 2 minutes, probably faster. Okay, I'm not saying rush, by the way, but I'm saying it doesn't take that much brain power. So I'm assuming everyone's done with that. It looks like it by the sounds of it. I say sounds, I'm not literally speaking to you, but judging by the fact no one's commenting that they need it on. Let's do question 8. So solve the equation. The equation looks like this. Okay, so that's the equation. So let's have a think. Now, if you've read ahead, you might think about using something called logarithms, okay? But keep in mind, the way I'm doing these videos is you don't need any future knowledge to come back to. So I'm not going to introduce logs here, okay? For those of you who don't know what logarithms are, don't worry, it comes up later. You don't need it for this question, and to be honest, I think it's easier without logarithms, okay? Here's the method for this style of question. First step, make the bases the same. That is the first step, okay? So how can I can't make 2 into 8, okay? It would be very complicated. So I'm going to make 8 into 2. Now 8 is equal to 2 to the power of what? 3. First step. Okay, so the first step in this style of question, if they ever ask you to solve that kind of thing, is to make the bases the same. Now let's expand. 3 times 2 is 6, include the x. 3 times 5 is 15. Equal to 2 to the power of x plus 1. Wonderful. So what is this telling me? Okay, so but bear in mind, you can do these questions basically 2 steps. Well, 3 main steps. The first step, make bases the same. The second step, okay, this is telling me that since the bases are the same, these top things must be equal to each other. They have to be, right? Because the bases are the same. So the second step, so again, this is the first step. The second step is to simply write 6x plus 15 equals x plus 1. Hopefully that should make sense, right? So let's you do a written example. So if 2 to the power of 4 is equal to 2 to the power of 2x, 4 has to equal 2x. Otherwise the values would be different, right? If it wasn't equal to 4, it'd be equal to, let's say, 3. That 2 cubed isn't equal to 2 to the power of 4. They have to be the same value. Okay, so for those of you that just weren't too sure about that, okay? So forget about that for now. So all I need to do is solve this, and this is a basic equation. This is literally like year 7 algebra, okay? Gather the x's to one side, so I'm going to minus x on both sides. 6x minus x is 5x, plus 15. X minus x is 0, so it equals 1. Subtract 15 from both sides. Because we want the numbers on the other side, we get 5x plus 0 equals 1 minus 15 is minus 14. Divide both sides by 5. X is equal to minus 14 over 5. That is my answer. Okay, so the third step is actually solving the linear equation. It's a linear equation, man. You know how to do these. It's easy peasy lemon squeezy. Let's give you a few seconds to do that. Okay. So that's another type of equation, type of question they can give you. Okay, is they can just kind of give you an equation to solve like that, and those 3 steps stay the same. So make base same, equate power, solve, done. 3 marks, 3 steps. Okay. Okay. Let's give you another few moments just to make sure that's all okay. Okay, let's move on to the next question. Question 9 is yet another type of question they can give you. I keep saying equation, it's bothering me. First one, solve the equation x squared minus 9x plus 8. Very disappointed if you weren't too sure how to do this. Well, okay, that's a bit harsh. Just use the quadratic formula and you're fine, right? So x is equal to minus 9 plus minus the square root minus 9 squared minus 4 a c, okay? And that's pretty much it. Okay, you can factorize if you really want to, if you find it easier. But I honestly don't see the kind of virtue in that. So just subbing that all into my calculator. Again, just turn your brain off for a second. And again, all I did is, I didn't rewrite the whole equation, I just changed the numbers in the previous one that I just did. So that gives me 8, and that's when I use the plus sign, and when I use the minus sign I get x equals 1. Splendid. That's it. 2 marks. Lightning fast, do it all on your calculator. You don't even technically need to write the quadratic formula. You just need the 2 answers and you get marks for them. Cool. Now it says hence. What does the word hence mean? It means using the previous part. Okay? Please, if there's anything you take away from this, make sure that's it. That's a key exam technique right there. So hence solve the equation. Okay. So there aren't really many similarities, right? But let's look at the similarities we have. Well, there's a 1 in front of the x squared, there's a 1 in front of the y cubed. There's a minus 9 in front of this, there's a minus 9 in front of this. There's an 8 at the end, there's an 8 at the end. Okay. If the structure of the equation is the same, what we can say is what they've done is they've said that x is equal to y to the power of 3 over 2. I didn't just pull that out of thin air. The x in this equation is y to the power of 3 over 2. The other thing you could have said is that x squared has been replaced by y cubed. So the equation is the same, but they've made a substitution. They've said x is equal to y to 3 over 2. Now, if you're wondering why this doesn't look the same, square root both sides. And you get x to the power of 2 divided by 2 is x. Y to the power of 3 divided by 2 is 3 divided by 2. So it's the same. They've made a substitution. That's all they've done. That's it. So all we need to do is use our answers. Well, x is either equal to 8, oh god, or x is equal to 1. So what do? Well, you square both sides, which gives me 64 equals y cubed. And then you just cube root it. Cube root it. And 64 cube rooted would give me, again, you can use a calculator or you can just know it, but it's equal to 4. So y is equal to 4. Or, now for the kind of people with those of you with foresight, you can see that this is actually just going to equal 1. Right, and let's look at it. So square it. 1 times 1 is 1. Then cube root it. Well, 1 times 1 times 1 is 1. So these are our answers. That's it. So when it says hence, please, 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 make sure you use the previous part. It's far quicker than trying to solve that by yourself. Okay? If you do further maths, you might be able to kind of think of a way to do that. But if you're doing a regular maths exam, you probably shouldn't be using further maths techniques. So I'll give you a second just to copy that all down, make sure that's all groovy. Okay. Okay. And if we get rid of that, let's do this. Question 10. Find the value of x such that 8 to the power of x plus 1 is equivalent to 4 to the power of 3x minus 1. Cool. So if you remember back up here, we did a similar question. And what was the first step? Make bases same. Okay, cool. So how can we do that? I can't make 8 into 4 by using powers. But I can use 2. I can make all of these 2. And 8 is equal to 2 cubed. 4 is equal to 2 squared. So if you have to, just keep going down, right? Don't worry about kind of leaving it up or anything like that, okay? Leaving it up. That didn't make any sense. What I mean is you don't have to make 8 4 or 4 8. You can make them into an even smaller number. Right, generally speaking, you're going to be using 2, 3, or 5. Okay, so keep those in mind. So let's do it. Let's do 2 to the power of 3 x plus 1 equals 2, power of 2, 3x minus 1. So now we have, again, we're timesing 3 times x gives me 3x. 3 times 1 is 3, and that equals 2 to the power of 6x minus 2. And what did we say now? The second step is to make powers equal. Or you can call them exponents. So we just equate. I should have said equate, that sounds better. Equals 6x minus 2. And the third step is solve. So bring all the x's to one side. This is the smaller x, so let's subtract 3x on both sides. We have 3 equals 3x minus 2. Bring all the numbers to one side. So if we want x on the right side, let's move it to the left. We have 5 equals 3x. Divide both sides by 3, and we get x is equal to 5 over 3. And that is our answer for that one. Okay, so again, 3 marks, and there's 3 steps, so it's not too tricky, I hope. Give me a second just to copy that down. Okay, so let's get rid of that. And move on to the next one. So, question 11, factorize completely. So, again, factorization is a big part of A-level maths as well for things like sketching graphs. Expanding brackets is also important for things like integration and differentiation when we come on to it. And also because sometimes there's a question that just says expand these brackets. That's it. So, all we need to do is do it. So, factorize completely. So what it means to factorize is, so a factor is just something that divides into a number, or into, in this case, something. So into our terms, what is the biggest thing we can divide both x and 16x cubed? Well, the only thing they have in common is 1, which I'm not going to bother writing, and x. We can divide both of these by x, we can pull that out. X divided by x gives me 1. 16x cubed divided by x gives me 16x squared. That is factorized completely. 2 marks. Pretty damn quick. Question 12, we can do something else as well. So we have 75x minus 12x cubed. So think about the different things we can probably take out from them. So first things first, can we take something out of 75 and 12? Well, we can take out 3, right? And then open bracket. Not open bracket, sorry. And is there anything we can take out of x and x cubed? Well, we can take out x. So 3x on the outside. What's 75x divided by 3x? Well, 75 divided by 3 gives me 25. X divided by x gives me 1. So 25 times 1 is just 1. Then minus, and again 12 divided by 3 gives me 4. X cubed divided by x gives me x squared. Not too bad, right? Now, expanding these. Okay, this is where people get angry, upset, confused. They go through the 7 stages of grief in rapid succession. This is really tedious, but it's not difficult. Okay? But again, it's very easy to make mistakes. I've seen people make mistakes many times. Here's what I recommend. So let's do 2x. Pick 2 brackets and expand them. I normally just do the first 2. So we're going to expand these 2 brackets. Okay, and you remember your FOIL? First, right? So we multiply the first 2 terms. So the first term of each bracket. 2x times x, 2x squared. Then we do the outside terms. So outside means the ones furthest away from each other. So 2x times 2. Then you do the inside terms, so the ones that are right next to each other. So minus 1 and x. So minus 1 times x is minus x. And then you do the last terms. So minus 1 times 2 is minus 2. And that is it. Essentially, all you need to remember is you need to multiply every term in the first bracket by every term in the second bracket. So 2x has to be multiplied by x and 2, and minus 1 has to be multiplied by x and 2. As long as you remember that, the order doesn't actually matter. So now how do we expand? Well, first off, we want to simplify this. Okay, I want to move the x minus 3 to the front as well, because I find it easier. But keep in mind, it really doesn't change the problem. You don't have to do it. 4x minus x gives me 3x minus 2. So is there a FOIL for like quartic or like a 3-term bracket? No. All you need to do is make sure x is multiplied by everything in this bracket. So what I do is I literally, I start with the x. I do x times 2x squared is 2x cubed. X times 3x is 3x squared. Oops. X times minus 2 is minus 2x. Then I literally put a dot on top to know that I've done it. Okay. Minus 3 times 2x squared gives me minus 6x squared for this one. And then minus 3 times 3x gives me minus 9x. Minus 3 times minus 2 gives me plus 6. Okay. So to know if you've done this correctly or not, right, we have 2 things in this bracket and 3 in the second. So we should have 6 terms in total, because we have 2 terms that are multiplied by 3 other terms in the bracket. Last step is you simply gather like terms. There should only be one, that's to the power of 3, so 2x cubed. The squared terms, we have 3x squared minus 6x squared. So 3 minus 6 is minus 3x squared. Then we have the x's, we should have 2x terms, minus 2x minus 9x, which is minus 11x. And lastly, we have the 6, which again, there should only be one value on there. Okay, so that's how we get to the expand and simplify from that. Okay, so hopefully that makes enough sense. So let's give you a few seconds just to kind of process that and digest it, so to speak. So again, you pick the first 2 brackets or whatever 2 brackets you want, expand those using FOIL, first outside, inside, last. Simplify, then expand again, just make sure you times each term by each other term. You should end up with 6 terms in total. Then when you simplify, it should come down to 4 terms. Okay, just give you a few seconds. So question 14 is actually very similar to question 13. Very similar indeed. So let's kind of apply what we just did yet again. So this. So the question 14, we have 3x minus 2 and then x minus 5 all squared. So if you remember what this squared means on top of the bracket, it means we have two copies of that bracket. So 3x minus 2, x minus 5, x minus 5. And again, what's the first step? The first step is just to pick two brackets and expand them. So it doesn't really matter which ones they are. So just to prove my point, I'm just going to always do the first two brackets. So again, let's use FOIL. So the first term in each bracket is 3x and x. So 3x times x gives me 3x squared. 3 times 1 is 3. X times x is x squared. Then you do the outside terms. So you do 3x times minus 5. So again, the outside terms are the ones that are furthest apart from each other. 3 times minus 5 gives me minus 15. X times effectively 1 gives me x. And then you do the inside terms, the two that are basically touching. You have minus 2 and x. Minus 2 times x gives me minus 2x. And then you do the last terms. So you do the last terms in each bracket. So minus 2 and minus 5. Minus 2 times minus 5 gives me plus 10. And that is going to leave me with x minus 5 in this bracket. First step, done. Okay, expand two of the brackets. The second step is to simplify this first bracket. So 3x squared, there should only be one x squared term so far. There are going to be two x terms, so we need to simplify them. Minus 15x and minus 2x. Minus 15 minus 2 gives me minus 17x. And then the plus 10 on the end. And then x minus 5. That's it. I personally like to write the smaller bracket first. But again, it really doesn't matter. Just make sure that every term has been times by every other term. So, again, start with the x, times that by everything in this bracket. So x times 3x squared, we just increase the power of the x by 1, 3x cubed. Next, x times minus 17x, increase the power of the x by 1, minus 17x squared. X times 10 means that there are 10 x's, so plus 10x. And then again, I'd put a little dot on top just to show that I've done the x's. Then you go on to the minus 5s. Again, make sure that you include the sign, because that is very important, okay? A lot of people make mistakes with that. Minus 5 times 3x squared, it only affects the number. So minus 5 times 3 gives me minus 15, and then the x squared stays the same. Minus 5 times minus 17x. So to times by, again, to be fair, you do always have a calculator in these exams, so you don't have to know this, but you can times the number by 10 and then divide it by 2. Either way, you get 85, and it's minus times a minus, so it'd be plus 85x. Whoops. And lastly, minus 5 times 10 gives me minus 15. And the last step, so this was the third step, is to actually expand the last two brackets. The last step is to then simplify. There should only be one cubed term. There are going to be two squared terms. So minus 17 minus 15 gives me minus 32x squared. And there should be two x terms. So plus 10x plus 85x gives me plus 95x. And there should be one number term or linear term, minus 50. And that is it. So again, you might think that this is a lot of work for just 2 marks. And to be honest, I'd agree with you. Sometimes these are worth 3 marks if you're lucky, but sometimes they're worth 2. It just depends on the examiner and how hard they think the expansion actually is. So, give you just a few seconds just to have a look-see. Make sure that's okay. So, just in the interest of time, the next question is very similar to solving. So what I really want to do is actually go on to some rationalizing the denominator, because we haven't had a chance to do that yet. So I'm going to skip that and go on to this question here. So I think that's enough time for you guys to have copied something down if you need to. If not, keep in mind this is going to be re-uploaded to YouTube, so you can just find the question you were on, pause it, and then copy down the answer. Okay. You can also pause live streams actually, so either way. Okay, so get rid of that. And we're going to go straight to question 16. So in rationalizing the denominator questions, they used to just ask you, and again, if you're doing some older exam papers, and I'd suggest you do them because the content's actually the same, they used to just say rationalize the denominator, or they used to say simplify. Now they literally tell you this. In fact, include this. It can be written as. It's a big hint. So to rationalize this denominator, I told you that you'd have to times by the square root. However, if you have multiple terms in the denominator, you can't just times by the root, because otherwise you'll still have a root in the denominator, right? So if I times this by root 3, right, this would disappear, but this would then be 2 root 3. So it wouldn't work, okay? So what you actually need to do is times by, keep this the same, but the sign in the middle has to flip. Okay. The reason why it has to change is because it will delete the cross terms. Okay. So for example, if I was doing, let's say I kept the sign the same, right? Expand using FOIL. 2 times 2 is 4. Outside 2 times minus root 3 gives me minus 2 root 3. Inside minus root 3 times minus 2 times 2, sorry, is minus 2 root 3. Minus root 3 times minus root 3 gives me plus 3. I still have square root. So to get rid of this, I need to make one of them positive. Okay? So, and don't forget, whatever you do to the bottom, you must do to the top to make sure the fraction remains identical in value. So let's expand this. So we're expanding these in brackets. So again, FOIL first. So 5 times 2 is 10. Outside 5 times root 3 is plus 5 root 3. Root 3 times 2 is 2 root 3. Root 3 times root 3 is just 3. All over 4. And I could cheat and not do the cross terms, but I think for the first time I'm doing it, I need to make sure you guys understand. Let's do the outside and inside terms. Once you get good at this, you don't need to do the outside and inside terms because you know they cancel. But first, okay, then outside we have plus 2 root 3. Inside you get minus root 3 times 2, which is minus 2 root 3. And the last terms are minus root 3 times root 3 gives me minus 3. So in other words, these two disappear. And that equals, so gather the terms. So we have 10 and 3. So we have 10 plus 3 is 13. 5 root 3 plus 2 root 3, you can add these together. So imagine that they were x's if you want to. 5x plus 2x gives me 7x, so you can treat that in the exact same way. So 7 root 3. Now what is that over? Well, 4 minus 3 is 1, so in other words, it's not over anything. It's 13 plus 7 root 3, which is your final answer. And if you look, it is also the answer here. Okay? So I think if we speed it, we can actually do the last question before this lesson's technically meant to end. So let's get down to business. 18. Show that, and then we have 1 minus root 2. Can be written as. So once again, we're going to do the exact same thing, okay? So we're going to times by the exact thing on the denominator, but we're going to flip the sign. And keep in mind, when I say flip the sign, only do it to whatever's in the middle. We're not actually changing the sign in front of the root or the sign in front of that. We're just changing what's in the middle. The reason why I say that is sometimes they write it as like root 2 plus 1. You still change the sign here. Okay, it's not the thing in front of the root. That's something that a few pupils get confused on. It's not the thing in front of the root, it's the thing in the middle. That's vital because we're getting rid of cross terms, okay? So let's go. 1 times 3, 3. 1 times minus 2 root 2 is minus 2 root 2. Minus root 2 times 3 is minus 3 root 2. Minus root 2 times minus 2 root 2. Okay, so let's actually go through this. This root 2 times the root 2 will give me 2. So this is basically saying what is actually what's a better way to word this? It will essentially be plus 2 times 2. So in other words, it's going to be 4. Okay? Because the root 2 and the root 2 times to make 2. Perfect, and that's it for the bottom, the top even. 3 times 3 is 9. And then again, I'm going to do the cross terms, but you don't have to if you already see the logic. Minus 6 root 2. Inside terms, plus 6 root 2. The last terms are 2 times 2 is 4, so minus 4. Then root 2 times root 2 is also 2, so that just makes 8. So simplifying this, we get 3 plus 4 is 7. Minus 2 root 2 minus 3 root 2 is going to give me minus 5 root 2. All over these two terms cancel. 9 minus 8 is 1, so it equals 7 minus 5 root 2. So in these questions, the denominator always equal to 1. It can equal 2 or something, and in which case all you need to do is cancel through it, okay? So that about does it for today. We covered basically everything that you need to know in terms of algebra skills, but we did it kind of briefly, okay? So it's not going to be 100%. You need to practice now. Again, if you have the textbook, that's perfect, or you can use kind of online resources if you want. Other than that, I hope you have a really wonderful evening.